Good morning, everyone. I hope I'm audible. Can anyone please confirm?
Yeah, good morning, sir.
Yes.
Commander Dev here from Naval Headquarters. You are audible.
Thank you so much, sir. So, good morning, everyone. Today we are here for we're continuing with the outreach of the DISC 14 Navy challenges. Yes, so we'll be continuing with the outreach for DISC 14 Navy challenges. Today we are going to be covering 4 challenges, and all these challenges are going to be based on the MiG-29K platform. So I would request the nodal officer to please take over, and meanwhile I'll flash my screen with the problem statement for these challenges. So over to you, please.
Yeah, good morning. I'm Commander Dev here for everybody to know. Good morning. I am from Naval Headquarters. I am the nodal officer. My name is Commander Heram Dev, and I will be steering this project on Navy's behalf from Naval Headquarters, Delhi. However, the problem statements, there are 4 problem statements pertaining to the units that are utilized for MiG-29K aircraft engine, and these items are critically required and are important for the operation and of the MiG-29K engine. These particular problem statements have been given to IDEX, and now they have been approved as part of DISC 14. So the Naval Aircraft Yard Goa is the maintenance agency for MiG-29K aircraft, which is operated by Navy. So they have prepared a presentation, a small presentation for the industry, so that the exact technical requirements of these particular units can be shared. May I please know as to which is the industry who has joined, or anybody has joined as of now with regards to these problem statements?
Good morning, sir. My name is Kantarao. I represent Part Controls and Communications Limited in Bangalore.
So my name is Arun. I work for Optimized Systems, which is test equipment company and also custom electronics.
Right.
Good morning, sir. I'm Punrit Pandey. I'm representing Navdrishti Aerospace from Bangalore.
Okay.
Good morning, sir. My name is Gagan Kaushal. I represent Trigarthaya Labs. We're from Noida.
Welcome. Anybody else is there?
Good
From
morning,
the
sir. This is Ashish from Magnum Dynamics, Hyderabad.
Okay, good morning, everybody, all the industry partners who are looking forward to taking on these DISC challenges proposed by Naval Aviation. So I will just request NAY Goa, Naval Aircraft Yard Goa, to start the presentation. Maybe they can share their screen and the presentation that they have prepared for the 4 challenges or the 4 items for MiG-29K. They can give the presentation. Anyway, Goa, you can start the presentation. Before that, I would like to just brief the industry partners who have gathered here. The requirement is that of these items are going to be installed on the aircraft, and some of them are directly installed even on the engine of MiG-29K aircraft. The MiG-29K aircraft is a MiG-29 aircraft specifically designed for naval version. Okay, so the aircraft is a little different from what Air Force operates. The MiG-29K aircraft operated by Navy is different from MiG-29 aircraft operated by Indian Air Force. Even the upgraded MiG-29 aircraft of Air Force is not exactly same as what MiG-29K aircraft of Indian Navy. So if anybody has got anything, sir, we have already worked on Air Force items. So it is going to be one-to-one production. No, it is not going to be the case. That is point number 1. Second thing I want to inform all the attendees is that these items are going to be installed on the aircraft and on the engine, there will be a mandatory requirement of semi-lac certification and QA coverage by DGA. So the industry will have to cater for these two things. Otherwise, despite the design and development is complete, we will not be able to install these items on aircraft, even for the testing purpose. Okay, and most importantly, the items design developed, there is no test facility available with Indian Navy. There is no test rig, there is no test bench kind of a thing. So most of these things, either you will have to design your own test setup, or if the things are proven certified, then we can consider them for direct installation on the aircraft and testing them on the aircraft. So this is the third point. And fourth most important point, which we have already clarified in our PDS PRU, that there is very, very limited technical documentation available with the Navy. The technical specs that we are flashing or that we have is only what the Russian side has given the Indian Navy, and there is not much scope of getting additional information on these aspects. So most of these projects will require re-engineering, or so as to say reverse engineering capability also. So these are the four things I would like to clarify before even we begin with this presentation. So over to NY Goa, you can share your screen and start your presentation.
Right, copied, sir.
Share.
Good morning to all the participants. May I know if I am audible and the screen is visible, the presentation slide is visible to everyone?
Yes.
Right, sir. Very good morning to all of you. Before we start, I would just take a minute to introduce the team here from Naval Aircraft Yard, Goa. So Naval Aircraft Yard Goa is the third, fourth line maintenance agency for the MiG-29K aircraft of Indian Navy. I am Commander Sabrish. I am coordinating all indigenization activities of MiG-29K and Kamov 31 aircraft. For this brief presentation on the basic technical specifications of these four items, I am joined by a few other officers, Commander Manish Rana, who is the Chief Manager of Avionics Workshop, Commander Jagannath Mishra, the Chief Manager of the Aero Engine Repair Facility, and Commander Vishnu, who is the Chief Manager of the Aircraft Production Group. So with this, I will begin. The first item is the Control and Monitoring Unit BAC 42. This is how it looks like. So the functions of the item, as flashed on the slide, it is designed to monitor and control the power plant RD-33 MK engines and the aircraft accessory gearbox, as well as the functioning of the air intake of MiG-29K aircraft. Now, for functioning, it also takes inputs from various other units, such as the fly-by-wire, mission computer, air data system, towards functioning of the aircraft and engines in various modes. And it's a very critical equipment for the aircraft performance and operation of the engines and the AGB, as its failure can result in inoperability of the engines as well as the associated systems. Next. So this slide depicts the basic technical specifications of the item. As Commander Dev from DAPP sir has already mentioned, the technical documentation is very limited. So we are briefly presenting whatever is available with us. Shall I move to the next slide?
Yes, sir.
Okay, so now as per the PDS-PRU, the scope of work is as flashed on the slide. The scope of work for the industry will involve a preparation of the development methodology, identification of PCB cards, identification of the software codes from the ICs fitted in these PCBs, and installation of the software onto the ICs. Next. The test procedure performance metrics, the item is required to be tested in all engine regimes, both ashore and afloat, post completion of the manufacturing at the firm's test facility. And as mentioned, the test bench for this item is not available. So integration end user trials, the item is required to be ground tested on aircraft and also flight tested, because there is no availability of the OEM supplied test bench. Next. So this was the brief introduction to BARC 42. Now we move on to the fire detector sensor, the next item, USP4. This is how the item looks like. Next. Purpose is fire detection and extinguishing in the engine and AAGP compartment. Operating principle, generation of thermoelectromotive force in the sensor when temperature increases beyond permissible limits. The conditions under which the sensors are activated is the temperature of the actuator with 3 sensors connected in series increases at the rate of 2 plus minus 0.5 degree centigrade per second, and the temperature reaches 300 to 400 degrees centigrade. Next. Specifications available as flashed. Weight of the item 61 grams. Dimensions as flashed. Power supply 27 volt DC and 18 volt DC in emergency mode. And resistance 0.4 to 0.6 ohms. Scope of work remains more or less similar. Preparation of drawings and development manufacturing technology. Identification of the sensitive elements towards manufacturing of similar sensor, and smooth integration of the sensor with the actuating unit, which is BI06. The sensor is again required to be tested in ground and flight trials, both ashore and afloat conditions on the aircraft. Next. The third item is a sensor called DBSKT, which is fitted on the engine, looks as flashed on the slide. It's an angle sensor designed for measuring the angle of fan IGV of the RD33 MK engines of MiG-29K aircraft. Principle of operation, it's a rotational variable differential transformer with 2 channels of measurement, main and standby. Criticality is that its failure can result in overspeeding and surge, leading to rotor shaft bearing damage and engine seizure. Reasons for failure, vibrations from the engine, contamination due to ingress of moisture, oil and dirt. Next. Specifications, operating temperature range as flashed, and power supply is, pardon me, there's an error, it is 24 volts. And weight of the item is as flashed 0.085 kg. Scope of work, preparation of drawings, design sensor needs to match exact dimensional and functional requirements of the OEM supplied item. And again, the sensor is also required to be tested in all regimes of engine operation, ashore and afloat. And since there is no test equipment available, it also has to be installed in the engine for functional testing. The fourth item is a pressure transmitter called RAPRIS, which is fitted on the engines. So there are 4 different types of these sensors. So this is the transmitter designed for measurement of air, oil and fuel pressure in the engine and give feedback to the engine monitoring and control unit BARC 42. Principle of operation is piezoresistive effect. Criticality is its failure can result in false warning like abnormal fuel, oil, and air pressure, thereby limiting engine operation. And reason for failure again same, vibrations from the engine, contamination due to moisture, oil, and dirt ingress. So these are the functional parameters of these 4x type sensors. The first one, the operating pressure range is 2 kgf per centimeter square, operating range 0.2 to 2 kgf per centimeter square, operating voltage as flashed. This is used for measurement of
2 is P in and P in and P1 and 2 inlet pressure, fuel pressure. And next is
the next one, which is in the pressure range of 10 kgf per centimeter square,
turbine pressure, air pressure,
is measuring the turbine air pressure
and anti-icing system pressure,
and anti-icing system pressure.
and oil pressure.
The third type, which is having a pressure range of 10 to 100 kgf per centimeter square, is for fuel pressure measurement. And the fourth one, the range of 6 to 60 kgf per centimeter square, is for compressor outlet pressure measurement. Scope of work remains more or less same, preparation of drawings, manufacturing technology, and the sensor also needs to match exact dimensional and functional requirements of the OEM supplied item. And integration test procedure again to be installed on the engines for functional testing, as no test equipment is available, and it will be tested in all engine regimes of operation, ashore and afloat. So I finished with this. We can move on to the discussions.
Thank you, NAY Goa. We are now open to the questions if any industry has regarding how to progress with the project. The two things I would like to make clear for the presentation, if there are any technical queries, Naval Aircraft Yard Goa can be addressed. In case of any issues with regards to the IDEX framework as to how to go about these projects through IDEX framework, Naval Headquarters DAPP, that is me, or IDEX will be able to answer all the queries. Open to now all the participants to have any question, to ask any questions.
Good morning, sir. I'm Pundrik Pandey from Navdrishti Aerospace. I just wanted to know, so as you said, the technical documentation is very limited, but we need to kind of reverse engineer the existing Bark 42 unit. So we will be provided the unit.
I would like to take on this. The thing is that now again I'll informing this to all the participants. What we can do is that now it will be very difficult to give a serviceable unit, and at times I'm not sure even the CAT B or the BER item, which is like beyond economic repair or scrapped item, whether we will be in position to give every time. Okay, notwithstanding what the mechanism that we have been following in such cases normally is that we allow the industry to go and visit the Naval Aircraft Yard Goa. They can visit the yard, they can see the laboratory, see the item in laboratory condition. They can go and visit on the aircraft and see where this item is installed, how it is installed, and if they want to have any data, they want to see the item opened up, they can visit the workshop. Aircraft Yard Goa can of course facilitate these things, and you can take all the data, you can see it, but it may not always be possible to give a item for checking or study purpose. So as far as possible, we will try our best to hand over this item. But if that is not feasible, the companies are most welcome to go and visit Naval Aircraft Yard Goa and do all sorts of checks and all the procedures they want to see, or whatever documentation available there, which in case at times cannot be shared with you directly, they can be given access to that.
Sir, Commander Sabrish here. May I add one more input to this? is that while as mentioned by Commander Hiramdev sir, clearly serviceable items cannot be spared, but we have a couple of items which are under repair in our workshop. So with the appropriate approvals, we can hand over the item as required. But the only constraint is that if too many firms are interested to take on this project, then we don't have those many number of items. One odd item can be spared that we can look into, sir.
Okay, thank you, sir.
Sir, in addition, we have aircraft wiring diagram and pinout diagram also with us.
So I would like to know if in terms of interface details, are any interface control documents available and which will have, let's say, the protocol details and the message details, or we have to reverse engineer all of that?
No, we don't have any ICDs with us.
Understood, sir. And second question is, approximately, do you know how many, physical cards are inside this back 42? Is it like 2, 3, or more than that?
There are total 6 cards inside one unit, and 5 are programmable cards.
Okay, sir. So right now, for the programmable cards, do you have any infrastructure available for reprogramming those cards, reprogramming the flash memory and the flash memory contents? Is it available right now?
No, we don't have anything. Presently, what we are doing is we are only repairing this item by intercannibalization. So any card level repair or reprogramming of software we don't do.
Understood, sir.
Sir, what the current system? What type of issues you generally face?
See, we have multiple failures of card modules, especially with respect to the power supply cards.
Okay. And I have one query, like in the presentation, it was shown that the operating envelope was -65 to 85. Is -65 very critical requirement, or -40 should be fine?
See, this is a Russian origin aircraft, so it is designed as per the Russian temperature and all.
Not enough because stratospheric temperature is -57.
Yeah. Original equipment is designed for Russian environment.
Just a minute, one input is there. Commander Vishnu has an input to your query, please.
The upper air temperatures are about -57, so we need to go until -60.
-57.
Yeah, so -60 is keeping some 3 degrees Celsius margin of error, and we need to have that -60.
-60 is what is required, right?
Yeah.
Okay, right.
So I think there was an input that the power supply card is one of the typical, failure points. So are you looking at the complete system being, redesigned or reverse engineered, or only the power supply card, which is the problem component?
It is not only power supply card. There is one exchange and check module card, which is a programmable card. So these two particular cards are faulty in most of the cases, and so we are not looking for the repair. We are looking for the refurbishment of these cards.
No, and present the present challenge involves, I mean, as per the PDS PRU which has been submitted, is the development of the LRU in totality, not just the cards.
Okay, here I would like to pitch in as Naval Headquarters. The project primarily aims at, having the functional unit which is matching the form and fitment. Okay, now specifically, let's say with regards to this BARC 42 unit, which involves a certain number of cards inside, which are doing several functions, primarily being the processing. One will be the input-output card kind of a thing. One will be the power distribution card. Apart from that, 2 or 3 maybe additionally processing cards. That's what the presumption is. Now, say for example, now this is the aircraft design and the equipment and the weight part is frozen. Okay, we cannot change much in that case. So tomorrow, if a company comes and says that, okay, this entire functionality can be compressed in a 1/4 volume of the LRU, that is also not acceptable. You may be functionally even superior than what this particular unit is doing, but then we want to have the form and fitment, basically the number of connectors which are going in, input outputs that are coming in and going out, they need to remain same. The functionality needs to remain same. However, the internal, once the external chassis is designed and kept same, internally, with superior technology available these days, a company may opt, okay, sir, instead of 6 cards, the entire job can now be done within 3 cards, or maybe within 4 cards, the entire functionality and even additional these things are available in case you want. So that is acceptable, but but in the bargain, sir, weight has reduced to nearly half. Even that may not be possible, because then that causes the difference in the center of gravity calculation for the aircraft. So when I'm saying this, the internal technology to the box or the chassis or the LRU is acceptable up to certain level. The external design, look, feel, and the size has to remain the same, including the connector mechanism. You cannot institute, sir, instead of these 5 connectors in the front, now we have changed everything to only one single connector of say 20 pins. No, that also is not acceptable. The rest of the system is not going to change, the rest of the aircraft is not going to change. So those external interfacing aspects have to remain the same. Internally, yes, we can tweak around a bit.
Sir, somebody has asked a query that circuit diagram is available. No, sir, we don't have any circuit diagrams available with us.
So, sir, in that case, if can we examine the circuit physically, or has any, let's say, an X-ray analysis being done of the PCB board?
No, nothing has been done. We have only aircraft wiring diagram with us and pinouts.
Okay, sir, because one of the things that is done in these cases as a process is that in case this knowledge base is not available, then along with, sir, what you have specified, the circuit is taken and an X-ray is done of the same. So that reveals the entire internal structure of the circuit, and then one can work and reverse engineer and simulate the various parts and check.
So it is a suggestion from your end. The industry wants to use this methodology. I don't think there is any restriction on that from our end.
Okay, sir. So then if we take the necessary permissions, then can we do an X-ray of the circuit?
Sir, may I request Sir DAPP to comment on this, please?
Yeah, Naval Headquarters here. I think there should not be any problem as far as you can give us an assurance that there is not going to be any internal problem by any mechanism you want to assess the structuring and the wiring of the item. We don't have
Yes,
any
sir.
problem.
We can share that later on, over formally. But just to bring it to the notice of the panel, this is not a unique problem that we are facing in the country. It's a problem that a lot of countries face, where systems are developed and the original teams or data is not available. So in that case, this is a very standard method of reverse engineering, where an X-ray is taken of the electric or electronic circuit, and then maybe taking a photograph of the parts, looking at the values. So for example, if there is a capacitor or there is an IC of a specific type, trying and matching, finding out those parts, and then you create an electronic equivalent or a digital twin of the circuit to validate whether your design is correct, and then you can fabricate it. So that reduces the risk significantly.
Yes, you can recommend these methodologies. We will definitely approve it if it fits all the requirements. Not a problem.
Thank you, sir.
So how many number of inputs and outputs will be connected to this input-output card, and what type of major sensor or actuators?
You are asking the system is taking input from which all systems and giving output to which all systems?
Yes, sir, exactly.
So basically the system is connected to 29 subsystems.
So does the problem statement clearly define what level of control authority is expected?
Yeah, if you see para 4 of problem statement and para 5.
All right.
Sir, when you say the system is connected to 29 subsystems, this 29 includes sensors and actuators?
Includes sensors and actuators.
There are, yes. Total 40 sensors.
By number. By
Sensors where?
नहीं बार किन से connected है सबसे ना
सबसे input लेता है
And what would be the quantity requirement, sir, when the agency is successful in realizing this?
So quantity, you mean to say number of units?
Number of units,
So,
yes.
Quantity, I will confirm naval headquarters here. Quantity we are immediately looking at is the minimum pilot order quantity in the all these project have been given as 10. Quantity 10 is what we are looking at, and depending upon the unit which you are looking at, the prototype requirement is either 2 or 1. Okay, those details are given in the PDS PRU. Anyway, you can comment on to the number of sensors integrated and the inputs. That question you can just take on, please.
So there are total around 50 sensors, sir, which are connected to the bar, and all the systems which are connected is already mentioned in our problem statement, sir. Para 5.
then ADS and
Okay, thank you.
Sir, one more input, sir, on this.
So there are analog sensors like some of them which are covered earlier, the Rapid sensor and the DBSKT sensor, etc., which are connected directly to the bark, where it is converted from analog to digital. And then there are digital systems like air data system, etc., which are interfaced with the bark through digitally. So there are different. The engine mounted sensors are connected directly to bark, and the other aircraft mounted systems are connected through respective systems.
So does that answer the query or any further clarification is required, please?
Yes, sir, it answers my query.
So, are there any further queries?
Yes, sir, you said that we can be allowed for reverse engineering, applying reverse engineering methodology like that circuit X-ray with right kind of assurance. So, what form this assurance will be? Means some certification or some permission?
Could you repeat your question, please? I was unable to hear it properly.
Sir, as you mentioned that we can apply our reverse engineering methodologies if with right kind of assurance. So what form we need to give this assurance in? Means some kind of permission, some certification or something?
What I can say is that the assurance of issue is not required. Basically, you need to just clearly bring out as to what methodology you are going to use, what mechanism, so as to say, to achieve the end result. How much time will it take? And since these items are available at aircraft yard Goa, so it's a defense establishment. So if you say, ki, sir, I need to take my equipment inside, then we also need a clarity on that. What is the size? What is this equipment all about? You cannot suddenly say, ki, sir, this is a small tempo full of equipment that I need to carry, because specific approvals will be required to be taken. Those approvals will be given by naval headquarters, as well as the local approvals will be given by the Goa naval area. So the single point contact for these procedure approvals will be me, naval headquarters, and you can take it up directly. My email ID is already being flashed over here. So you can straight away send an email to me, and we will facilitate your visit. Although you will have to clearly bring out what exactly you intend to do, how you intend to do, and what all things, and how many people will be involved. So based on those details, we will guide you as to how to go about.
Okay, sir. Thank you.
So in case there are any further queries, you can also submit your queries through the IDEX website. So if once you visit the IDEX website, you can scroll to the bottom and you'll find the this query section over here. So you can either email us at these email addresses, or you can use the form on the website. So if there are no further queries, we can close this session.
So are there any queries on the other three items which were shown?
No, sir. No queries. Thank you.
Sir, I think there are no further queries at this moment. So we can close this session. Sir, meanwhile, you can please also share your email ID in the chat. I was mentioning to the nodal agency.
SMIC डैश नेवी के बाद फिर नेवी डॉट जी नहीं सर SMIC डैश गोवा पक्का
So for attention of all, I have shared the mail ID of IIC Goa, that is of NAY Goa, in the chat box. So if any queries, any further queries or anything which the industry wants to confirm or clarify subsequently can be addressed on this mail ID as well.
And further, I have from the naval headquarters side, I have shared our email ID. If any firm wants to, visit NAY Goa, they need to first approach us, keeping Naval Aircraft Yard Goa as the info addressee, and we will see as to how to facilitate your visit.
Right. Thank you so much, sir, for the information on the systems. So, with this, we can conclude these sessions. Thank you, everyone, for joining.
Thank you. Naval Headquarters signing out.
Thank you so much, sir.
Leave medical.